We appreciate your attendance. Thank you to those of you who've joined previous energy storage webinars with us. And welcome if you haven't joined before. This is a series we put on about commonly asked energy storage questions. So in previous webinars, we've answered questions like, if I have grid-tied solar, why does it stop during a power outage? How do I add storage to an existing grid-tied solar system? And many other questions. So today, this is a unique one. One I believe we haven't done before ever at Soligent. So we're very excited to have Madeline on, our energy storage manager, to discuss some of our energy storage solutions we offer today. So this will be an overview, so not quite technical or in-depth into those solutions. So if you do want more information in regards to some of these solutions, please reach out to one of your account managers here at Soligent. And if you don't have an account manager, don't be shy. Please email me, marketing@soligent.net, or Madeline. We'd be more than happy to get you into contact with a solar expert on some of these solutions. So Madeline, thanks again for joining us today, and we're excited to run through some of our amazing energy storage solutions.
Thanks, Jamie. Appreciate it. All right, without further ado, Soligent's energy storage offerings. Here we go. So I'll just tell you a little bit about myself. Compare just the general architecture of the solutions that we have, and then just dive right into the various brands that we support, and reviewing kind of really a wide variety of types of energy storage offerings. So my name is Madeline. I have been in the solar industry since 2016, and starting at that time, I was doing sales for grid tie and battery-based systems. Back then, in 2016, most of the inquiries for batteries were going to be for fully off-grid systems, typically. And that's what I kind of saw at the beginning. And then really, I would say in the past year to 2 years, the grid tie space has really gotten a wide variety of solutions in the marketplace. And in this picture, I'm actually with the Panasonic Evervolt, which we have available and launched this year. So my goal at Soligent is to help installers and to help installers' customers, so the homeowner, understand how storage works and why storage is good for your home. And I help do this by hosting these webinars that are hopefully digestible to anybody interested in learning about batteries, as well as kind of connecting our vendor partners and the applications engineers from all of these individual brands to connect with people on each project to ensure that the products they're using are going to work for their application and are going to work the way they expect it to work. So if we're just going to talk really high level, the main distinction between an AC coupled solution and a DC coupled solution is the presence of a grid tie inverter. So in this case, if we look at this schematic, starting from the solar panels, we're going to connect them to our system via a grid tie inverter. So we're going to have alternating current coming out from the get-go. Then all of the power from our PV is going to go into a critical load panel on the home. It's really important that in most, if not all, of our grid-tied battery-based systems right now, we're tying to a critical load panel. And the critical load panel is going to be where any of the loads that you want to run during an outage will land. So in a typical house, you have your main service panel. You know, you've looked at this before, your breaker box, where all of those switches are. That's your main service panel, and that's where every single load in your home is tied to. However, when you add a battery-based system, you're typically going to only back up the essential loads you need during that outage. So you're going to take those critical loads and you're going to remove them from the main load panel, and you're going to give them their own box. So we want to take our PV and tie it to that critical load subpanel via the grid tie inverter, and that's going to power our critical loads during an outage. Then here's our AC coupling portion, we're adding our battery-based inverter. So our battery-based inverter, also known as a hybrid inverter or an inverter charger, this is going to be where the critical loads are fed and the battery. So this is going to be kind of our new key component so that you can connect any output from the battery to your critical load panel, and any additional power from the PV can still go to the main service panel. Then any of your remaining loads are still going to remain, and then the grid. So our offerings for AC couple include the Enphase Energy Ensemble. Outback has the Radian you can AC couple, and the Skybox. And the Skybox has coined their true hybrid inverter. Panasonic with the Evervolt, which you saw in that picture on the previous slide. Schneider has the XW Plus and the XW Pro, and you can AC couple the SW, the smaller version as well. SMA's kind of premier grid-tied product is the Sunny Boy Storage. You can AC couple the Sunny Island, but I'm going to focus on the Sunny Boy Storage today. And then Sonnen. Sonnen's Eco and Eco Links product lines. For DC coupled solutions, again, we're still going to be having a battery-based inverter in this solution. However, the distinction here is that our PV is going to be going directly to the battery from its innate DC state. So we are not inverting it right out of the gate. We're taking a charge controller, or in some cases, the charge controller element is kind of inherent in the battery-based inverter, but the technology is still the same. The concept is still the same. Our PV is being controlled in some DC capacity and charging the battery via the battery-based inverter. Then our next relationship still is between our battery-based inverter, our hybrid inverter, and the critical load panel that's going to be getting AC power. So charging our battery from our PV and DC, and then we're inverting at the battery-based inverter and feeding our critical load panel. So this is kind of the DC architecture if we're prioritizing charging the batteries. That's the key takeaway, that when you're in DC, the efficiency is highest for charging your batteries rather than focusing on feeding the AC power to your home or to the grid. So our options for DC coupled include Generac, the power cell, Magnum with their PAE line, you can DC couple. Midnight Solar has basically a lot of different offerings from they're bundling all of the offerings that we have. So you can get a pre-wired Magnum from Midnight. You can get a pre-wired Schneider from Midnight. You can get pre-wired SMA from Midnight. So Midnight is doing a lot of the assembly so that you're getting it in one big package. Outback Power, again, you can DC couple the Skybox because it has that, again, the true hybrid inverter functionality. You can also DC couple the Radian. Panasonic has a second Evervolt line. So they have two distinct products, the Evervolt for AC coupling and the Evervolt for DC coupling. Schneider, XW Plus, XW Pro. And then we have the Simplify Access units that you can DC or AC couple. The Simplify products have the Schneider inverter with the Simplify battery or the SolArc inverter with the Simplify battery. So I want to stay on this slide for a minute because this kind of relates to your critical load panel. So when PV array to cover your entire roof because you want to get net metering and you want to maximize your net metering, but you also want a small amount of backup for when an emergency happens. So if you have, let's just say, 20 kilowatts of PV, you might want 15 of those to go on the main service panel. And those are going to be 15 kilowatts of regular old grid tie PV. Then you take the second 5 and you put those on a critical load panel. And that additional, or that distinct 5 kilowatts is going to go on the critical load panel with a battery-based inverter. So you're going to have all of your battery-based components separate. And in this case, I want to make sure that whenever you're configuring your critical load panel, you know how much power is being fed to it from the battery-based inverter. So I just listed a few examples. 23 amps, a few offerings have 23 amps as an output, pretty standard. The next up for an individual inverter is typically 33. So the 69 is an example of stacking 3 inverters in parallel. So on a single critical load panel, we may have 1 inverter, or we may have the ability to increase inverter power on 1 panel so that we don't have to de-aggregate and have distinct critical load panels for each battery. So the thing I want to note about your loads is always, how long do you want them to run? That's more of a function of how much battery capacity do I need, but do your applications have a surge value? That's going to increase your amperage. That's going to increase the power needs. So what are the power components that you're going to be needing that will be fed at any given time from your inverter? Figure those out so that you can adequately size how much power you need. So here's just an example of some loads you might pick. So fridge, 900 watts roughly, a furnace fan, cell phone charger, a few lights. These 4 loads equate to 1.6 kilowatts or 6.7 amps at 240 volts. This is very modest. You could have this certainly running from any of these 3 given power situations. Then I want to just kind of incrementally increase what we may consider our critical loads. A well pump is going to add a lot, and then some lighting. So we just increased our loads by adding 2 additional lights and the well pump to our original previous 4, and now we're at 2.7 kilowatts. Again, still very much within the needs if we're looking at our 23 amp circumstance. Moving down the line, let's throw on a TV, a microwave, and a coffee pot. Again, we're assuming that all of these loads may potentially run at the same time, because knowing that they're running at the same time means that we're going to be using the full capacity of the inverter. If you somehow had a switch and you said, if coffee pot is on, do not run the microwave, then we could decrease our maximum need by roughly 900 watts because you would only be using one of those loads at any given time. Again, we don't want to get confused with how much battery capacity we need, because if we're running the coffee pot and then we're switching immediately to the microwave, we're still going to need all of that energy capacity, but we may not need that maximum amount of power to peak as much. Adding a washing machine, that's getting up there. So now we're pretty much at our 5.5 kilowatts by adding the TV, microwave, coffee pot, and washing machine. I want to note that in all of the stuff that I mentioned before, we do not have any major air handling needs. A fan is fine, but once you start getting into air conditioners, even mini splits, you're going to drastically increase the amperage needs of your inverter. So now I kind of want to just add these really, really big loads as a way to explain why they may not be included on your critical loads panel. So our air conditioner, they vary in size, but any kind of medium to large central air conditioner can be running around 6 kilowatts at any given time. Similarly, an EV charger and an electric oven are both over 6 kilowatts. So essentially, you could have this entire house full of minor loads, if you will, on one critical load panel, and then the air conditioner would need its whole separate, unique system just to power the air conditioner. So that's kind of the magnitude of power needs that we're talking about. It's really a lot, and it's hard for homeowners to wrap their heads around because when the grid is up, we're really fortunate. I'm running my air conditioner full blast. I'm charging my EV. I'm heating something up on my oven. Like, when you get into emergency mode, it's a lot different because these things are powerful. So I just want to be upfront on how you look at loads and how you prioritize them, particularly based on how much power they use. Okay, let's dive into the options. Sonin. We're going to do AC coupled. I think it's a mix. This is an AC coupled option. The Eco and the EcoLinks. So Sonin is a really interesting brand because they have been one of the oldest battery-based residential offerings in the market. And they started in Germany and have 50,000 plus systems installed. So a lot of experience. They know what they're doing. Shell acquired the Sonin name, or the Sonin brand essentially, back in February of last year. So strong backing. Don't necessarily have to worry about, is this company going to be around? Is my warranty going to be upheld? Shell is their owner. So the Eco product line is their typical home storage solution. The options are between 5 and 20 kilowatt hours. And I would say a typical backup may be between 15 is probably 10 or 15 is like the minimum kilowatt hours, I would say, for any kind of most of the things you would want to be running for a few hours at a time. So for the 10 and 20 kilowatt hour units, the AC output is 33.3 amps. On each of these slides, I kind of want to highlight what are the options of each product line and what's our amperage output so that you have a gauge on that. The EcoLinks is with home automation integration. So it has a little bit more advanced like load shedding, load management capabilities, more integration with any smart home features you would have, like smart lights. And another thing I want to mention before I dive in with all of these brands too much, I'm kind of giving the brief brand overview. We have done full Sonin webinars, and we have a full gamut of deep dive into each brand, but I'm just going to give it the overview. And then even if you or your sales team want me to kind of do something like this overview, but with only 3 brands instead of 8, that's very doable. So this is an indoor unit. Oh, this pictured is the EcoLinks. The EcoLinks is black and the Eco is white. And if you can see, there's a teeny sliver of a line. This is the kind of original unit, and then below is the battery extension cabinet. So you can add more batteries if you want to. Indoor installs, there is generator capabilities for up to 12 kilowatt generator. And then the last line I'm including is the warranty line. And I want to talk about megawatt hour throughput of the batteries. This 10,000 cycle 10-year warranty is often arbitrary when we're talking about battery cycling because it's hard to know how much is a cycle. What amount of your battery are you really using? So the megawatt hour value is a true representation of the charging and discharging amount you're using for your unit. So in this case, the Eco 10 has a 58 megawatt hour throughput. That's enormous. I think that 58 megawatt hours for a 10 kilowatt hour system is the highest amount of a warranted battery. So take that into consideration when you're thinking about cost, because megawatt hour throughput is really a good indicator of what a warranty represents. Enphase, the Ensemble line, is just rolling out. So Enphase has historically been a microinverter company, a module level power electronics company They have 23 million microinverters shipped worldwide. Interestingly, though, the N-Charge battery is the 3rd generation battery. They started with versions 1 and 2 of the AC battery, and that was kind of intended for a self-consumption, kind of getting into the self-consumption market, primarily in Hawaii. And there were 30 megawatt hours shipped of those 2 product lines. So not their first rodeo. This is our 3rd generation battery, and the Ensemble is really a full fleet of what you would need for battery solutions. So Enphase is compatible with the IQ microinverter line. So if you have a house with an M215, they would need to upgrade to the IQ series. It could be the IQ6, IQ7, any of those, or the IQ8s coming out soon. And then you could add between 3.3 and 40 kilowatt hours to your system. With the 40 kilowatt hour option, that is the equivalent of a 15 kilowatts AC output from your microinverters. So this is a really powerful system. 15 kilowatts of output, you're probably able to include one of those bigger loads with 15 kilowatts continuous. This is an outdoor rated product for, again, even though it's a NEMA 3R, it's outdoor rated, I want to mention the operating temperature range because that's going to affect its functionality as well. Generator integration, not yet, it's in the works. And then again, I want to focus on 28 megawatt hour throughput is rated for the N-Charge 10. I think there was one other thing I wanted to say. So the Ensemble product line is going to include the N-Charge battery. You can get it in a 3 or a 10 kilowatt hour unit. Oh, here's what I wanted to add. In this box, we have our battery element, of course, but it's also equipped with IQ8 microinverters. So the IQ8 microinverters that we're going to be getting and putting on our roofs are already part of this technology in the N-Charge. So if you needed to do any maintenance on the system, let's say you have a 10 kilowatt hour battery and it's not outputting all 10 kilowatts to kilowatt hours, you could swap out one of the IQs that's in there and put it back in. So it's very modular in terms of maintenance because it's made up of these microinverters that Enphase is so accustomed to building that it's easy to do maintenance on these systems. The N-Power, so there's the N-Charge and the N-Power. The switch is sort of your communication device, physical interconnection between the batteries and the microinverters. And then, of course, the on-board communication. So you have the switch, the battery, and the microinverters from this product line. Generac. So Generac has historically been a household name in the home standby generator market. They are a behemoth. However, Generac wanted to transition and get into the energy storage space, and they did this by acquiring Neurio, which was a home energy management software company, and Pika Energy, who was a inverter and battery technology company. And by doing this, now under Generac, we have the power cell, which is their inverter and their battery. So this is the inverter down here, this little guy. And then this is our battery enclosure. And this can hold between 3 and 6 battery units. So that means that we're going to be getting between 8.6 and 17.1 kilowatt hours of storage per enclosure. But we can do 2 enclosures on a single inverter. So if we wanted 34 kilowatt hours, we would have 1 of these inverters and 2 of these cabinets with 12 of the batteries filling those cabinets. So Generac is a DC coupled solution, which means that you just need the modules and these 2 components. However, to connect the modules into this system, we have the PV Link and the Snapper. The PV Link is essentially a string level optimizer. So you can pair between 2 and 9 modules, basically up to 2.5 kilowatts per PV link in order to tie this in to the inverter. So the inverter has 4 30 amp DC ports, and between those 4 you can add PV or batteries, because again, it's a DC coupled system. So you can do up to 6 PV links, and that would go onto 2 of those ports. So we can do 15 kilowatts of PV on a single inverter. And this is a really important thing to note, because if we have 15 kilowatts of PV, we can take, let's say, 7.6 kilowatts and invert that and go straight to the loads, but then any excess PV power we can be used to charge the battery bank. So the reason you would want to oversize this, I don't even want to like think about the AC-DC ratio, that 130% rule, if you're familiar with that, isn't really applicable in this DC coupled case, because we're prioritizing charging the battery first, and then we're able to feed the loads. So even though 15 kilowatts may seem like way too much for a 7.6 kilowatt inverter, we're not going straight to the loads. We have charging the battery to prioritize too, so it really is advantageous. This inverter is a 33 amp output indoor unit for the battery. Generator integration will be coming soon. And then again, this is a 30 megawatt hour throughput for the 11.4. So for a single one of these stacks, you're getting 30 megawatt hours warranted. I think I want to harp on the fact that the PV link and the snapper is such a good way to pair this PV into a system. You know, you don't need it for any new install. We don't need to worry about a grid tie inverter and a battery based inverter from an AC coupled perspective. So we're just going straight to the PV link and the snapper. So the snapper is an inline rapid shutdown device, and it looks just like a little MC4 extender. It's really sleek, easy to use rapid shutdown piece of equipment. Panasonic. Okay. So this is the white version of the Evervolt, and I was standing next to the black version. One is for the AC coupled and one is for the DC coupled. Panasonic has been around, you know, it's a household brand name. They've been in the solar space making modules for ages, and they've been in the battery space since 1931. So, you know, something to note too, they make all of the cells for the Tesla cars right now. This is their first energy storage system, to my knowledge. And the Evervolt product line is really nice. It's, in a lot of ways, it's similar to Generac in the sense that they have a DC coupled version, but then it's similar to, let's say, Sonin, because they have an AC coupled version. So Panasonic kind of is spanning any use cases you might have. If you have a retrofit, you can AC couple. If you have a new install, you can DC couple. Something I want to mention is stacking, DC stacking. In this case, we can stack up to 3, meaning you could do 3 of this whole system. So you'd have 3 inverters, and let's say in our case, 3 battery stacks on a given singular critical load panel. And this is really important to note. So if you have an EV charger, let's say, that you really want to back up, you can increase your power output by adding multiple inverters on your single critical load panel. So again, we have 11.4 kilowatts for a single enclosure. You can do 2 enclosures per an inverter. And so 102 kilowatt hours is our max. If we're doing 3 inverters and 6 battery stacks, we can have 102 kilowatt hours of energy. This is an indoor installed unit. Yes, already generator compatible. And then here, I just took this little snippet from one of their data sheets. But if we have 2 stacked, that's 9 kilowatts or 46 amps of output with 68 kilowatt hours. And then with 3, that's 13 kilowatts of output, 69 amps of current, and 103 kilowatt hours, or 102 and change. So lots of power, lots of energy capabilities when we stack the DC Evervolt system. So I want to make that, you know, it's not the cheapest solution per se, but it's very powerful. If you have someone that knows they want a lot of power, absolutely think about DC coupling at Panasonic. Moving to SMA. So SMA, of course, another household name when you think about solar. 2 gigawatts of battery-based inverters installed. You know, they've been in the game with the Sunny Island for ages. But the new Sunny Boy storage is it's a great option, especially when you're AC coupling with a lot of PV. So a few minutes ago, I kind of mentioned this story of if you have a 20 kilowatt array and you want some backup, you might take 15 and leave it on the main service panel, and you might take 5 and put it on your critical load panel. In that case, you're going to have some sort of inverter to take care of that 15, and then a second inverter to take care of the 5. If someone has, let's say, an 8 kilowatt PV array, you can use a single Sunny Boy storage inverter with up to 9.6 kilowatts of grid tie PV. That's substantial. So remember that 9.6 kilowatts of AC coupled PV is really a significant amount for a single inverter. So the Sunny Boy storage product line, this is using LG Chem, the Resu-C line, or BYD. And with BYD, you can use 10, 20, or 30 kilowatt hours, because there are 3 battery inputs for this inverter. So you can have, hypothetically, or if you wanted to, you could do 2 LG Chems and 1 BYD, because the battery inputs are all distinct. Okay. The inverter itself is a 25 amp continuous output. However, when we pair it with the automatic backup unit is kind of similar to the N-phase switch. The automatic backup unit has a 50 amp output, meaning if the sun is shining and I have a Sunny Boy, because I have an AC coupled system, the output of the PV can be going simultaneously with the output of the batteries. So I'm able to get more output by kind of channeling both systems at the same time. I'm getting output pulled from the battery, and I'm getting output from PV and the Sunny Boy via the automatic backup unit. So that's why I want to say that the 25 amps is if you're only thinking about the battery. You can get more power if the sun is shining. Indoor or outdoor installation up to 122 degrees. This is a grid tie node generator solution. And then 24.9 megawatt hours that's the BYD warranty throughput rating. So in this case, it's kind of what's called a 4-pronged product. Your grid tie inverter, let's call it a Sunny Boy, the Sunny Boy storage, battery-based inverter, the automatic backup unit, which is kind of the whole physical integration where you would tie in all of the AC and DC inputs and outputs, and then your battery. Okay, Outback. The Outback story is a multi-tiered kind of, it's a really good story about where did Outback come from? Why is the Outback named Outback? I encourage anyone to find the answer for that story. It's a really good story. But Outback now is part of the Enersys group. Outback was acquired by Alpha a few years ago, and then Alpha was acquired by Enersys. So Enersys is an enormous company. Alpha was almost 900 million in sales. Enersys is over 2 billion. So Outback is, again, in good hands in terms of a warranty backing standpoint. So right now we're going to talk about the Skybox. This phrase, the true hybrid inverter, is a really good one because you can DC couple it. If you want to AC couple it, you can AC couple it. If you want to program it for really intricate time of use needs and backup, you can do that too. So there's a lot of configurations that the Skybox is capable of, and it's really novel for that reason. the single unit is a 24 amp output. It's a 5 kilowatt unit, period. There's no surge. So 24 amps is what you're going to get. If you want more, you can do 2. Stack the 2 in parallel, we get a 10 kilowatt output, we're happy. This is a low voltage solution, so you can pair any 48 volt battery with it. If you want to do lithium, great. If you want to do flooded, great. You can just set your battery voltage set points in your configuration when you're commissioning, and everything will work as long as you know the parameters that your battery is operating under. This is an outdoor rated unit, which is great. So if you have a ground mount, you can stick it out there underneath the ground mount, and it is compatible for generator integration. So lots of functionality here. Radian. These are probably familiar to people that are kind of been in the industry for a long time. We're going to go over this. This is the pre-wire flex power. Here's a Radian inverter. This is the hybrid inverter, if you will. 2 charge controllers. I think these are FM100s. And then here's our mate. This is where you do all the controls. And this is the GSLC. This is the load center that goes with the Radian, where everything's going to get tied in. So DC and AC inputs and outputs are all wired into the GSLC. So you can get this prefabricated and purchase this from Outback, the pre-wire solution. They have pre-wires that are just this. So you get the charge controllers. You can also get AC coupled bundles, which do not include charge controllers. Or you can get the whole kit and caboodle with their system edge, which also adds the IMO Fire Raptor rapid shutdown equipment and batteries with a battery rack. So lots of different levels of pre-wired solutions from Outback, which really helps, especially for people who are just getting into the battery-based space. When they do all the pre-wiring, it takes a lot of the legwork out. This is one of the FXR series. This is a Flex Power 1. So we have one of the inverters. Again, this is a hub. This is for kind of communication integration. This is the mate, and this is the Flex Max charge controller. 80 or the 60. So a little bit smaller input capacity than the FM100. The Radian is a 240 volt line. So if you have split phase loads, you might want to consider the Radian. There's a 4 and an 8 kilowatt option, but you can stack them up to 10 inverters. So size is kind of not an issue with the Outback Radian because you can engineer it in such a way that you can get a ton of power if you need a 10. The FXR is the 120 volt, common for small cabins, or if you have any, like, let's say a shop, like a power tool shop with 120 volt loads, this might be a great solution. Wall hanging unit, indoor rated for both, and generator integration for both. Schneider Electric. Similar, Schneider has been around in the solar game in a similar capacity to Outback. And again, I encourage anyone to learn about the Xantrex Schneider historical story. Takes you back before my time in the solar world, that's for sure. So Xantrex was around in 1983. The Connex line, is all kind of a part of Xantrex. Like, people still refer to Xantrex XWs, but now it's the Schneider. Schneider is the Xantrex brand. So since 2008, Discover Battery, I briefly want to mention because they are a lithium ion battery provider, and they have kind of a BMS integration with Schneider. So XanBus is the communication protocol that Schneider uses, and Discover also has XanBus communications in their battery cells. So this is kind of deeply integrated. If you were to get a Discover battery with a Schneider inverter, they're going to be highly compatible, highly communicative, easy to see your state of charge type thing. So that we have the XW Plus and the XW Pro. The XW Pro originally came out because of California's increased standards But I think that the Pro is really kind of leading the way. This XW Plus you can still install in other parts of the country. But the Pro is kind of our next step forward because we have an improved kind of next level communication with the Insight and the Gateway. The Gateway is our next generation communication system. You're still going to use a system control panel like you would, but instead of the former communications, you're going to switch to the Gateway, and then the new communications platform is called Insight 2. Again, this is a 48-volt system, so you could do a Discover lithium battery, or you could do flooded. You can stack up to 4 inverters pretty simply. And in this case, you would use a power distribution panel. That's kind of the equivalent of a load center for the XW line. Indoor rated generator integration. I'm not including really much warranty information on these because we're not referring to any batteries. The megawatt hour throughput is typically associated with the battery cycling rather than just this inverter, because I'm talking about the inverter line rather than a battery line, because you compare many battery lines with any 48-volt configuration to the Schneider line. Magnum. Magnum is part of Sensata, so another kind of conglomerate. The PAE line, most typically for like larger applications, is going to be the 4448, but you can get you can get multiple Magnum products ranging from 2 kilowatts to 4.4 kilowatts, or in 12, 24, or 48 volt solutions. You can stack these for 4. The PT100 is a really big charge controller. 6,600 watts on a single charge controller is substantial. But I really want to talk about the Magnum mini panel, or the Magnum panel. So again, this is another load center similar to the power distribution panel for Schneider or the GSLC for Outback. The Magnum panel, there's many different versions depending on how you want to stack. So if you have different like inputs and outputs, if you say I want 2 inverters and I want multiple ACs in or multiple ACs out, you can configure your Magnum panel based on your inverter circumstances. So it's very customizable in that sense. And I really like that load center. Indoor rated unit, generator integration, yes. So Magnum has kind of been around in a lot of cases in the mobile application. So RVs or marine, like if you have a houseboat type thing. Compact, scalable, really another off-grid leader. So again, I mentioned briefly that Midnight is pre-wiring solutions from other people. So in this image, this is a Samlex inverter. They provide AC coupled, off-grid, or grid tie with battery backup solutions. So you might think, what's the difference between these? So one may or may not include a charge controller. If you already have a grid tie inverter, you wouldn't need a charge controller. And then it depends on the functionality of if you're fully off-grid versus grid tie with battery backup, you would need to sell back if you have net metering capabilities or kind of zero net export. Off-grid, you don't have to worry about the grid, but with grid tie battery backup, you have to have more programmability to consider what the grid might do. So the smallest solution from the Midnight pre-wire is a 2.2 kilowatt, 12 volt. Just for the nomenclature, when you look at this and it says 2212, the first 2 digits are referring to the size of the inverter, and the second 2 digits are referring to the voltage of the battery bank. So 2212 is also known, like if I said 4448, it would be 4.4 kilowatts, 48 volts DC. We have lots of different pre-wire product line. I mean, really across the board. And again, Midnight designs their own load centers. So you have the E panel that would be corresponding with a given inverter. The pre-wiring is really nice. It makes it easy to configure when you're just basically plugging in the batteries, plugging in your load center, the critical load panel that you have. for your home, and then the batteries. Generator integration, yes. So lots of different models to choose from. Simplify. So Simplify is historically a battery provider, and their story is also unique. They started from an e-bike. They got into this e-bike, and I actually asked them, I'm like, you guys still making this e-bike? Like, can I see one of these? But the e-bike has since not been a part of their product line any longer. In 2007, they switched to lithium ferrophosphate, which is touted by many as the safest lithium chemistry. So impressive that Simplify has been in the lithium space, specifically in LFP, since 2007. So it's a good thing to know if people are, concerned about safety or longevity. Simplify has been doing this for 13 years now. The Phi product line, most typically we're selling the 3.8 kilowatt hour battery unit seen here. In this enclosure, this is 6 of those battery units in the enclosure. So you can see the little Simplify logo on top of each of these units. This is the Simplify, the Phi product in the Boss enclosure. So this is the Boss 6, and then this is the Access enclosure, but you could also get the Boss 12, which is for a 12-unit battery enclosure. So the Access product line is, if you open this up, is going to include batteries down below and then a hybrid inverter up top. So you can get them pre-wired with Schneider or with Solarc. With Schneider, you can have them with or without the charge controller if you want that to be an AC coupled or a DC coupled version. Solarc is AC and DC coupled by nature, so there's no charge controllers that you would need to worry about. This is a NEMA 3R enclosure, so this is an outdoor rated product. You can have generator integration with both the Schneider and Solarc model options. And if we send this PDF out, you can click on this hyperlink. It'll take you to the Simplify battery sizing estimator. So we love a good tool to help you decide how much energy you're going to need for a system. So again, Simplify is a battery manufacturer for lithium ferrophosphate battery units, but they also have paired with Schneider and Solarc for pre-wired solutions with all-in-one. And last but not least, STEM. So STEM was not in our little AC or DC coupled comparison, but STEM I want to talk about distinctly because they are our commercial solution. So STEM has been in the commercial and utility storage space for 10 years. Most notably, as of late, they acquired 345 megawatt hours from Advanced Microgrid Solutions. Advanced Microgrid Solutions was another company in the energy storage space. They're kind of transitioning into more software-only artificial intelligence. So they have moved over their equipment to be managed by STEM. So STEM is very experienced when it comes to understanding how to deploy large-scale energy storage. Typically, the smallest solution, which is a 110 kilowatt hour system from Tesla, that's our smallest, and that could be in a 2 or 4 hour duration. And then the largest would be a 2 megawatts. That would be 2 megawatts with up to, I guess you could do up to 8 megawatt hours. We can do the AC coupled typically with grid services, or we can do AC coupled with backup as well. Right now, if you are interested in getting into commercial energy storage and you say, hey, I'm working on like 500 kilowatt, or even 500 kilowatt hour project, maybe STEM's right for me. Highly recommend the STEM University training. They have 3 online training portals that you can go through to get familiar with their product and their offering. Energy Toolbase is a proposal building tool that you would use to see which STEM solution is going to fit. So if you have interval data, if you have utility information on a given site, you would input that into Energy Toolbase, and then the output would say, okay, let's use a 111 to 222 kilowatt and kilowatt hour solution, and then that would be the STEM system. So it's Sungrow or Tesla hardware with STEM, artificial intelligence, software programming of how and when to deploy that hardware. So we recently did an Energy Toolbase webinar, so you can learn about how Energy Toolbase works and how Energy Toolbase relates to STEM. Okay, that was it. A little longer than my typical 30 minutes because we had a lot of brands to talk about. Again, I just want to reiterate, this is an overview of each of the brands. If one of these piqued your interest, you can find tons of webinars on each individual brand's offerings and why one might be better than another for a given application. These are what we have and what we think are the leading grid tie and off-grid solutions for residential and commercial energy storage systems.